AxLabs is a Swiss tech company that specializes in software and infrastructure engineering for the blockchain space with open protocols and decentralized solutions. An extremely talented group of software developers and designers, they are best known in the NEO community for their critical work in creating tools for the N3 platform that support Java smart contract development. Those that are familiar with their excellent work already know about their powerful Niao3j development toolkit. Niao3j is an open source development toolkit that provides easy and reliable tools to build Neo dApps and smart contracts using the Java platform, and is used by well-known companies in the blockchain space like Binance, OKEx, and others. I am very pleased to have Claude Muller here today, an AxLabs software engineer who is going to give an intriguing presentation on the generic DAO model that they are implementing for grant shares. A DAO, or Decentralized Autonomous Organization, is a powerful paradigm shift where the rules that govern an organization are encoded into the smart contracts that comprise it, instead of concentrating power in the hands of a centralized authority. Hello, Claude. Please tell us a little bit about yourself, AxLabs, and what your perspective is on DAOs on the Neo N3 platform.
Yeah, hey, Robert. Thanks a lot for the introduction. So I'm a software engineer. I've been in this industry for about 3 years, since 2019, I think. Pretty much since then with AxLabs. I'm generally interested in distributed systems, and I think blockchain is a very good example of distributed systems, obviously. And it seems that blockchain could make our future more efficient and more fair, I would say. So it gives us kind of purpose, right? Bit of idealism. That's why I like this industry, but it's moving a bit too fast in my taste. Whatever. So I've been with AxLabs since 3 years, like I said, and AxLabs was a very good match for me. We have similar goals and values, and like you already said, Robert, AxLabs found its niche in the Neo community with the Niao3j SDK and DevPack. We came into Neo when there was no good support for Java, and we took that opportunity to build the Niao3j SDK, and then later top it up with the Niao3j DevPack. And so now you can implement the whole dApp panorama with Java if you want to, so contracts and backend and front end. And yeah, that's for AxLabs, and now we have the opportunity to work on the grant shares program. And yeah, the grant shares program is a DAO, or has a DAO at its core. And about DAOs in Neo, there are not so many yet, or maybe there are none. I mean, there's governance on Neo natively, of course, built into it, where you can vote on council members, but then the council members are the ones that actually do the changes on parameters, or, for example, who is an Oracle node, that kind of stuff. This is a bit different to, for example, other blockchains like Dash, where you have governance built into the chain, and you can actually distribute funds through that governance mechanism, so that they have a bit more going on natively. And besides this kind of native blockchain internal governance, there's so as far as I know, there's a Neo Burger that tries to go into the DAO direction. So they are planning to become a DAO at some point, and they're working on it at the moment. And we will stay in communication with them to have to see what their experience is and what way they are going. We were already in contact with them. And in their case, it's going to be a token-based DAO, which means that if you have BNEO, or maybe they're going to do it with the other token they just released. If you have that token, then you can take part in the DAO, or in the governance mechanism. And for grant shares, on the other hand, this is going to be different. The DAO that's going to be at the core of grant shares will be more like a permissioned DAO, where you have a set of initial members that can vote on proposals, and of course you can have proposals that add new members or take members away. Yeah, I hope that answers your question.
Yes, it really did, and thank you. One thing I would like to know is, can you tell me what the general purpose of grant shares is? I mean, what it does, and how does the DAO model fit in with it?
Yeah, so yeah, I just presumed everybody knows it. So the grant shares is an initiative from NNT originally. Pretty sure it's NNT. Somebody rolled the credits, but whatever. I'm sure it's NNT. And the idea is to have a grants program besides what Neo Foundation already provides. It's something that could also apply for much smaller projects, and maybe not even technical ones. Maybe something like, you want to host a regular meetup group, or have give a presentation at an educational institution. And grant shares aims at projects like that, where those could ask for grants and get funding for their projects. And it's also important to have a grants program that has that where the decisions are made by the community, or by important members of the Neo community. So it's not only Neo Foundation that can give away those grants and grant shares, but it's important community members like COZ or Neo St. Petersburg Center of Competence, NNT, of course. So yeah, that's the reason why grant shares is an initiative, and AxLabs has the opportunity of doing the DAO, which is at the core of it.
So does grant shares allow direct contributions from end users and voting directly from end users, or is it a delegated affair?
Yeah, the idea is, like I said before, that's a permissioned DAO. So we will have, in the beginning, the initial members will be a select set of community members, like I said, COC probably, and these big names. And they are the ones that are going to vote for proposals. And the broad community could also have a say, but we plan to only have that more it's to see what the community, the whole community's opinion is, but it will not directly affect what is happening in the DAO.
Okay, great. Thank you. Now, are you ready for your presentation?
Yeah, sure, yeah.
All right, take it away.
So as you can see, the title is generic governance. And first I want to say what I mean with that. It's about not having a DAO contract that has many different proposal methods, like create project proposal or create change parameter proposal, but it should just have one method for creating proposals, and that method can be used for any kind of action to take with that proposal. So the proposal is basically just an intention of what should happen when the proposal is accepted. And so you can hear me talking about proposals a lot. So the proposal is obviously at the core of a DAO or of a governance mechanism. And I'm just quickly want to show this picture here, which is the life cycle of a proposal. So if let's say you want to get funding for a project, you would create a proposal, and then that proposal goes into the review phase first, where you cannot yet vote on it. You just people can discuss it and have an opinion form an opinion on it, and after that period, then the active phase comes, and there you can actually vote. Then that phase passes, and before you can actually execute the proposal, you will go into the queued state. And this state is kind of meant for is a bit of a security mechanism, that if the community then sees that, okay, that proposal is actually malicious, or we don't really want this, even though we accepted it, you would still have some time to abrogate it, to come up with a second proposal, so-called abrogation proposal. But if that doesn't happen and the queued phase is over and the proposal was accepted, then it can be executed, and that's where this flow ends. And this is something that you will see in many other DAOs as well. This is not something new. This is kind of a standard life cycle of proposals that can be seen in other DAOs, for example, on Ethereum. And what I'm going to show in the code that I'm showing, I left out these phases. I'm not enforcing these phases because that's just bloating the code too much for this demo, just so you know. But if you would implement a real DAO, you probably want to have these phases in there. Okay, and with that, we can switch to the code. So I already set up the basic setup for a Java contract on the left. So let me know if the font size is too small. I can still enlarge it a bit, but I think it's fine. We use Gradle in Java for managing the build. You can see here that the build file from Gradle. We're importing the Niao3j dev pack, which is the library you need for implementing smart contracts with Java. And we have the dev pack test down here, which is used for testing your smart contracts. And this is all you need for implementing smart contracts here with Java. So here we have our main contract, just a skeleton. We have the deploy method that's standard, and some of the manifest attributes we can set up here. And of course, when you implement a smart contract, you probably want to have tests at the same time. And so we have a test class that supports our contract. And this is pretty much like normal JUnit testing, but you have to annotate your test class with this contract test annotation here. And then you can configure your test. First, you need to know that the test will be run on a Neo Express instance. And so these configurations here affect the Neo Express instance that this test will be based on. First of all, you can set the block time. We just set it to the minimum possible here, to 1 second, which is also the default. And then we have a config file that configures Neo Express. I already added that here. If you have used Neo Express before, you will know this. Here we added 3 accounts, Alice, Bob, and Charlie. So we already have access to their private keys. And then we have an init.batch file, which sets up Neo Express with a couple of commands in the beginning. So these commands will be executed before any test is executed. So we just distribute some gas to all the accounts and some Neo to Alice specifically. And then, of course, you have to set the contract that you want to have compiled and deployed. And this is a list, so you can add multiple contracts here. At the moment, we're just working with our generic governance contract. Then another important part is the contract extension here. This is basically your gateway to things related to the underlying blockchain that is running, to Neo Express. And you can see down here in the setup method, we're using the extension, for example, to get the Niao3j object, which is your interface to the Neo node. So with this one, you can do the RPC calls. We can also get the contract that was deployed before, and we get the private keys, or I mean, just the accounts of Alice, Bob, and Charlie. And so we have these static variables that we're going to use later in the tests. All right, so now we're set to start implementing. And first of all, we want to be able to create a proposal, right? I have some templates set up here, so I'm just gonna paste the whole method. You can see that when we create a proposal, we want to know who proposed it. So you cannot use different account for proposing. You have to have the private keys for this. We're going to check the witness later in the method. And then there are these intents, and that's exactly the generic thing I was talking about. The intent, an intent is something that you want to have the proposal execute. So when a proposal is accepted, the intents of the proposal will be executed. And so let's go ahead and create this intent object here. We're going to have a target contract. And a target method. And then parameters that we will pass to that method. So you can see, well, it's also a constructor here. You can see that the intent is made up of the contract, of the method of the contract to call, and of the parameters to be passed to that method. So basically, it's a method, a method invocation in the end. So when the proposal gets executed, the method on this contract with those parameters get executed. Right, and then at the end, we have this discussion URL. So we assume that this discussion of the proposal happens somewhere, for example, on GitHub in an issue, and this URL is is part of the proposal. Okay, so the method body, we first want to make sure that that the proposer is also the signer of the invocation transaction. And now, in this version that I'm implementing here, we're not gonna save the intents and the discussion URL in the smart contract. We want to save some gas here and not use the storage. So what we're going to do is we're going to hash the intents and the discussion URL, and we're going to use that hash to identify the proposal. So obviously, if the hash is the identifier, then the intents and the discussion URL are also the identifier. So the intents and the URL uniquely identify the proposal. And this is important for later when we execute the proposal, because then you have to provide the intents and the description URL again. And only if you get to the same hash as before, you will be able to actually execute the proposal. And for this hash method here, I'm just gonna implement a pseudo method, which should not be used in reality, because I'm just hashing the intents and the discussion URL together. And if you do it this way, and then an attacker could come with create a proposal with a certain set of intents, but then execute the proposal with another set of intents that, when hashed, will result in the same hash, and obviously then they can execute whatever they want. So in a real contract, you would have to be more careful with this hash proposal method, but we don't have time for that right now. All right, so we have the hash. And now we can already store some information of the proposal, just so we know that there is a proposal with that hash. So we need a storage map where we can store proposals. So let's set up the storage map for proposals. We'll give it any prefix here, doesn't really matter. Okay, we have our storage map, and now we can save some information about this proposal. Let's first create a proposal here. So we have kind of a class for that. Let's create a class for it. So we have as you've seen, we have a proposal hash. And we have a proposer. And then later we will have yes and no votes. So let's add those. Right. Of course, in a real implementation, you could have a lot of different attributes, executed, canceled, information on the state, and so on. Let's add a constructor here. And then the yes votes and no votes, we're just going to set to 0. Like that. All right, so this is all the information about proposal that we store. So let's set this up. We have the proposal hash and the proposer. And now we can add this here to the storage. So we got to For the key, we're going to use the proposal hash, and then we'll serialize the proposal object into storage. And we'll return the proposal hash so that the caller knows what hash their proposal hash has. All right, now we have the first method, and of course we want to test this. So let's go back to the test. So for time reasons, I've prepared the tests. I'll just copy in a test right now. There we go. So just going to try and step through the basic flow of a proposal. Of course, first we have to define a proposal. We'll have Charlie being the proposer, and he has these intents here. Well, just one intent, actually. He wants to transfer one neo over here from Alice to Charlie, to himself. And yeah, you can see the target contract is the neo token, the target method is the transfer, and then we have the parameters. We have a discussion URL that is a dummy URL here. And then we're ready to call the create proposal method. So we have the governance contract here, right? We got that before from the extension, so we have access to it. We can invoke this function on it, create proposal, with those parameters that we just defined. And then we'll sign it with Charlie's private key. And then after sending the transaction, we'll wait a bit until it's on a block. And then we'll go and check the application log if the proposal hash is there. So let's run this. And if everything is fine, we'll just see the proposal hash. And yes, there we go. There's the proposal hash. All right, so we've created a proposal, and now I want to be able to vote on it. So let's create a vote method. So for the vote method, you have to pass the proposal hash, obviously, to identify the proposal. Then if you want to vote yes or no, and who you are, who is voting. Because now, as I said before, we're working here with a permissioned DAO. So you want to make sure that only people that are members of the DAO can vote. So basically, we're just going to assert that the voter is a member. So we need this member storage. Let's create another storage map up here. And we give it a prefix of 1. All right, so we assume we have our members stored in this storage map. And now we can check if the voter is in that map. So should not be null. And if he is, then we also check the witness. So if the transaction that invoked this is actually signed by the voter, like this. And if not, then not authorized. All right, and at this point, after that, we know, okay, this is a member and they are eligible to vote. So now we can retrieve the proposal from storage, like that, and deserialize it and cast it to our proposal. To a proposal object. And now we have access to proposal. And so the only thing that we want to do is actually set yes or no votes, right? So we're just going to check if the vote is true or false, and we're going to set the yes votes if it is true, just increment it. And if not, then increment the no votes. And then we're going to write the value of the proposal back into storage. Like that. All right. Of course, in the real world, you should then do null checks here. For example, if proposal.get returns null, you cannot deserialize it. So you should fail more nicely if you get null here. I'm just doing this so it's for brevity. Okay, then now we can extend our test, and we can go and vote on the proposal. And by the way, if you're working with phases, so let's say you created a proposal and now you have to wait until the review phase is over, where you cannot vote because you want to vote in the test, but you cannot because there's the review phase. And so what you can do is use the extension and fast forward a couple of blocks, and this will just add these blocks to the blockchain pretty much immediately. And then you're in your review phase, in your voting phase, and you can start voting immediately. So you don't have to wait for all these blocks in your test. I'm just gonna again copy the test code that I prepared. So we're gonna call the governance contract. We're gonna call the vote method with Alice and Bob with the proposal hash from before, and they're both gonna vote yes for the proposal. But of course, we need to remember that we need those people to be members, otherwise they will not be authorized. So, I mean, somehow initially you need to set up an initial set of members in your contract. So we're going to do that here in the deploy method. We'll add the members in here, and we'll expect that the data object holds an array of members, of initial members. So we'll cycle through those members here. We'll assume that this is an array of script hashes, and we'll add them to the member storage. So let's take the member and this value, and well, we have to map it to something because it's a key value store. And let's just say we're going to map it to the block number on which they have been added to the contract. So let's add the block number here like this. All right. So this is how we set up our initial members. And of course, we have to configure the test now to actually put Alice and Bob into the initial members. So with an EFTJ, you can configure your test and the deployment of your test with a deploy config. And I'm also going to copy this here. This will look like this. So you just write a static method that returns a deploy configuration object, and you annotate it with deploy config. And in here, you tell the test framework which contract you want to configure. And so we're configuring the generic governance contract, obviously. And so in the method, you set up a deploy configuration object, and this is the object that you then configure. And at the moment, we're just going to set the deploy parameter to Alice and Bob. And these two then will be passed into here and will then be added to the member. You can also do other things like set a signer. So if you want to set a custom signer for the deploy transaction, you can also do that here. Maybe the signer has an influence on how your contract is set up, this kind of things. All right, so now everything is set up. Alice and Bob are members, so we should be able to vote just fine. But then we should also be able to check that somehow. So let's add this here. And we want to get the proposal that we just voted on and check if those votes are actually correct. So we'll just need a small get method in here. Yes, also I've prepared that. So we'll just return from the proposals storage map. We'll get the proposal with proposal hash, and we'll have to deserialize that. All right, that's it. And we can mark this with safe because we know this is not going to change any of the storage of the contract. It's a safe method. This just appears in the manifest. All right, now you should see, after running this test, that the proposal has 2 votes. Right, we see the proposal hash. And afterwards, we see again here, that's the not so nicely formatted, of course, proposal hash, proposer, 2 yes votes, 0 no votes. So all is fine. Right, we created the proposal, we voted for the proposal, and now we want to execute the proposal. So let's add an execute method. As you can see, the execute method has, again, the intents and the discussion URL. And that is, as I said in the beginning, the proposal is uniquely identified by these 2 things, and we're not storing the intents in the storage because we don't need to, because you can just, again, pass it here. And now if we hash them again, and they actually match the intents and discussion URL from the create proposal method, then we will find the proposal in the storage. So let's get this hash here, proposal hash, and check the proposals map for that hash. And as you can see here, if the hash proposal method is not implemented properly, then these intents could deviate. It could be different from what has been passed in the create proposal method, even though the same hash is the result. And then you just execute whatever you want, and not what has been voted on. All right, so let's get the proposal, deserialize it again. Not serialize, deserialize. And cast it. Okay, and now we need to check, has the proposal been accepted? So let's get the whole vote count. We get all the yes votes. We get all the no votes. And now we can check. We need to assert if there's more yes votes than no votes. I mean, depending on what the acceptance rate is, we're just going to say we need the majority. So, and because we cannot work with fractional numbers, we're just going to work on a percentage basis here and multiply times 100 before we actually divide by count. Otherwise, if we don't do this, then we'll always floor to 0 and we'll not get to the right result. So okay, now let's say we just need a majority, so bigger than 50% or equal to 50%. Okay, 50% itself is not the majority. That's a detail. And if that is not true, then the proposal is rejected. All right. And now, if that has been passed, that check, then we can, if it has been accepted, we can execute the intents. So we are going to call whatever is in the intents. Wait, so we need a for loop actually, because we have multiple intents, or possibly multiple intents. So intents dot length. So we're going to cycle through them to enter this. All right. And let's grab an intent from here and call that intent. So intents target contract, the intents target method. We have to set some call flags here. We're just going to use all because we don't know what the intent wants to do. Maybe it needs all. And then the parameters. Okay, and you probably want to know the results of these calls. So let's return the return values and set up an array of return values with the same size as the intents. And then we're gonna set those in here for each intent. We're gonna set its index in the return values. All right. And that's our really simple execute method. Yeah, let's go and test it. Again, I'm gonna grab the code from over here. And now again, if you wanna skip some phases here, you do extension, fast forward a couple of blocks, and then you're in the next phase where you can actually execute the proposal and you're not locked. It's not necessary here now, it's just for showing. Okay, then we want to execute proposal, so we call execute. We pass again the intents that we defined at the beginning. Same from here, which Charlie defined. The discussion URL again. And now we're signing with Alice, which is a bit weird. Because the intent is also a weird intent because it takes money from Alice and gives it to Charlie. And of course, our generic governance contract cannot just take Neo from Alice without any permission. So we'll just add a global signer for Alice here so that this works actually. And then in the end, we want to see if that worked. So we're going to check Charlie's NEP 17 balances. And if there should be one Neo now, because Charlie didn't have any Neo before. And of course, he has some gas. So let's see if that worked. And yes, we can see here, there's one Neo, a couple of gas as well. So our basic proposal flow works. It's pretty nice. With this flow, we can do whatever we want, like all kinds of intents. You can come up with weird things because you can call multiple contracts and multiple methods of those contracts and so on. The test that we just did is a bit off, obviously, because we're taking money from Alice, which we don't do without Alice's permission, of course. So in the end, what we would have, if we're talking about funds and grants, then we need a treasury, right, which has funds that the governance contract can use. So we're going to just set up a treasury contract, generic. And for brevity, I'm going to take the code for that from over here. All right, that's our treasury. A pretty simple contract at the moment. It has an owner. That's one important aspect. The owner will be our governance contract. So for the only important method here on the treasury, the owner is important because only our governance contract should be able to release funds, right? And so that's what we check here. We get the calling script hash, and only if that is the owner, so we get the owner from storage here, only if those two match, then you will be able to actually call this method. So if we set the owner right in the beginning, so we set it to the governance contract, then this will just be fine and nobody else can just release funds from this contract. Of course, we also need this on NEP 17 payment method, which allows us to send funds to the treasury. We're not doing anything at the moment in here. Probably in a real world scenario, you want to be whitelisting accounts in here. I mean, checking if accounts are whitelisted. Because if you just get funds from any account, I don't know, probably you get legal issues at some point if you spend those funds on projects and those accounts then want their funds back. So a whitelist would be a good option here. Yeah, let's just go with that easy treasury contract. And what you can do, release funds is you can release any kind of token to a receiver and an amount, and the sender will always be our treasury itself. So we get the executing script hash, which is the treasury contract, and then we call the transfer method on that token with those parameters that we have set up. So you can send NEO tokens, gas tokens, or any other tokens. It depends, of course, on what funds the treasury actually has received prior to this call. And if we want to test this now, we don't have to change anything with the generic governance contract. the governance contract is not bound to the treasury, but the treasury is bound to the governance contract. So if we want to test this now, we have to add in our test, we have to add the generic governance treasury. So it will be compiled and deployed automatically, and it will happen in this order. So first the governance contract, and then the treasury. And after that, we want to have access to it. So let's also create treasury contract here and get it in the setup from the extension so that we have access to it later in the test. And as I said, we need to set the owner of the treasury contract. So what we need to do is also create a configuration for the deployment of the treasury contract. So let's add that here. Again, deploy config, this time with the treasury. And we have a new parameter here, the deploy context. And you can use the deploy context to, in this configuration method, to get the generic governance contract, because we need the hash of it here as the deployment parameter. So because of the ordering up here, we know the generic governance contract has been deployed already, so we can get its script hash and add it as a deployment parameter. And now we have set up the deployment for the treasury, and it will be deployed correctly. And let's write a new test that now tests releasing funds. So let me grab the code from over here. Again, same process, defining proposal, creating proposal, voting, executing. This time, we're gonna set up here this gateway to the NEO token, and we will transfer, first of all, some tokens from Alice to the treasury contract. We're gonna transfer 100 NEO. We know that Alice has 1,000 NEO from the beginning. So let's give it 100. That's the treasury's funds. And we can work with that. And now in comes Charlie again. Charlie does a project and wants some funds. So it's going to set up a proposal with the intent to take funds from the treasury contract. The method that is invoked is the release funds method that we saw before. And the token he wants is a NEO. And he wants 20 NEO for that project. Again, some dummy discussion URL that we need. And we're ready to go. Create a proposal. Signed by Charlie again. We will see the proposal hash here when we execute this. Again, we vote with Alice and Bob. We have set up this that they are members before. That's all fine. We can leave this at that. They will both accept the proposal. And then in the end, we execute it. And here we can use Charlie now as a signer. We don't need to have it as global because not as before where we took funds from a kind of a personal account, which is we're taking funds from the treasury now, and it's the governance contract that controls the treasury. So the signer is not important here. And in the end, we'll again check if Charlie has received the NEO. We'll print out the balances. And we're only running this test now, so we don't have to be afraid that Charlie has anything else than 20 NEO. That the NEO from above from the other test will not play into this. So yeah, you should have 20 NEO in the end. Let's see if it works. And yeah, here's the 20 NEO. So Charlie created proposal. People voted on it. Somebody executed it. And what has been executed is the release funds method with the NEO token. And because it was a proposal on the governance contract, this check passed and the transfer actually happened. And yeah, so you can see you can do all kinds of things with this now. One nice thing is that you can also update your governance contract through a proposal. So you don't need any special rights for, maybe a multi-sig address that has special rights on this contract. You don't need that. You can just create a a proposal that wants to update the contract, and that will work just as what I've shown you now. So what you need is an update method like this. In order to update a contract, the contract needs to call contract management itself. So we need this method here. But then you can just you create an intent. That intent's target contract is the governance contract. The intent's target method is the update method, and the parameters are a new nef and a new manifest. And then this check here, if the calling script hash is the executing script hash, will pass, because the generic contract, the governance contract, will call itself from here, right? It will do this. So it's the calling script hash and the executing script hash at the same time. And then we'll just update the contract. And so yeah, you have the whole governance contract lifecycle is controlled by proposals and by whoever has the power to vote on proposals. And that's the end of my demo. Thanks for the attention.
Thank you very much, Claude. That was a very interesting demo. I did want to ask a quick question personally. That fast forward function, that only works with the private net?
Yeah, I mean, you cannot do that on the mainnet. Not with we don't support so Harry has released some fancy features for debugging where you can step forward and backward, but this is not part of our test framework here. So no, you cannot do that with testnet or mainnet. What we'll do in the future is that you could run your unit tests on the test network if you want to. So we're just going to swap NeoExpress with the test network basically. But then of course some methods like fast forwarding are not going to be available.
Yeah, I would think that'd be fairly impressive if that was possible. Okay. Jesse, do you see any questions highlighted in the Discord?
I sure do. They interestingly enough come from Gil, where he says, first, in the unit tests, Claude used to print the values, but could you show asserts in the unit test instead of printing? Like devs are used to check whether a value is equal to something or whether a value is not null, etc. Can you expand on that, Claude?
Yeah, I get your question, Gil. I mean, I'm sorry that I didn't use asserts there. This is obviously not the way to do unit tests with system outs. So, I mean, what you should do here is something in the way of assert that. Let's get this here. That Charlie's balance. We would have to get the Neo token, and yeah, I think then we have the value of the Neo balance, and that should be 20 at this point. So yeah, this is how we should do it in a real test. Oh, that was the wrong import. But yeah, I think that's what he meant. This was just for showing you that something happens actually in the output. I'm not going to implement all these system outs with asserts now, sorry.
No worries. On to the second question. Does that sound good, Claude?
Yep.
Also from Gil. What if members of a DAO are token holders? For example, only token holders can vote and or create proposals. Which areas of the contract you showed would need to be changed?
So the members, the only power of the members is basically voting, right? Everything else happens automatically by the contract, or anybody can call execute or create proposal. And so this is the part where we would have to change things. And I have to admit that token-based DAOs are more complex or more complicated to implement, and because you have to, depending on the proposal, or you have to take time into consideration, and because you have to have checkpoints at which you know which user has how many tokens, so that if you have a time period of 7 days in which you can vote on a proposal, and let's say I have 10 tokens. So then on the second day I vote with a support of 10, and then I send my tokens to another address, and then on the third day I vote with that address also with support of 10, and suddenly I have a voice of 20. So I kind of have to have a checkpoint at the beginning of the proposal's voting phase that tells me which voter has what support, and I mean how many votes has which voter. So this is more complex than having a permissioned one, which is not based on tokens. I hope that was clear.
I think it
Yes.
was. Thank you. All right, Claude, we've got another question from Paresh. Hey, that was really interesting. I saw that you used the assert and it didn't throw an exception. Is there any difference?
You probably mean difference to a real exception, right?
Right.
And there's not. Well, so we implemented a compiler such that you can use the Java's assert statement as if you would be throwing an exception. You could just replace this with an if and else throw exception, or just if this is wrong, then throw exception. But this seems much nicer, and obviously this is a bit of an analogy to Ethereum's or to Solidity's require. So we kind of saw this Java's assert statement just perfect for this application here. And yeah, in the background, if the check fails, then an exception will be thrown with this exception method. We just wanted to use the assert opcode in the background, but there you cannot pass a message in. And if you're just failing without messages, that's never nice for the developer, obviously. So yeah, no difference, just nicer code.
Great. Thank you, Claude. We've got another question from MyVision7. A little bit off topic. He saw the Bitcoin Suisse talking a lot about blockchains on Twitter. Why are they never covering NEO? I was pretty hyped after reading the PDF doc where NEO was quite covered. And I think it was from you, Claude and Gil. Thanks for your time. Great work. If you want to expand on that or elaborate a little bit more or have any more insight on that.
Yeah, I don't have direct insight into Bitcoin Swiss. I mean, they're an established company. Not sure what their size is now, but it's big enough to be slow already, I would say. And I think their choice of which coins are covered depends on their users. I mean, they're covering NEO. You mean covering it in their news outlet, I guess. I mean, you can of course hold NEO with Bitcoin Swiss. That's possible.
Right. I think they were talking more about that, like Twitter coverage about the articles in their report from last year or from the beginning of the year.
Yeah. No, I can't really tell. Of course, we are in contact with them every once in a while. And like as Gil said right there, we are planning to get into contact again in January with them. So we hope that there will be more noise about NEO from Bitcoin Swiss in the future.
Good. I think that probably answers part of the question. And then also, if you can see from RutCam, they put in, I believe, a little picture here. If you wanted to answer that question as well, if you could see that on your screen, Claude, I'm not sure.
Yeah, no, I can see it. Yeah, exactly. This is pretty much the same. Yeah, it's the same outcome in the end. It's just that with the assert, I think, it seems more concise to me.
Just out of curiosity, Claude, is AxLabs going to be actually helping to code the grant shares contracts?
Yeah, we're lucky to be the main contributors to grant shares. So this was kind of like we're in the process of developing it now, and this was just to share a bit what our experience was so far with doing this in this area of DAOs.
And when is grant shares expected to go live?
I hope I'm not saying anything stupid now, but no, we're planning. I would say till the end of around Q1 and beginning of Q2.
All right, while we're waiting for other questions to file in, here's something from Boris OG.
Yeah, near for the win, I agree.
Yeah, absolutely. I did want to get maybe a little perspective from you. How do you see Neo ID fitting into the DAO paradigm?
Yeah, good question. Well, as soon as you use an ID, it's going to be a permission DAO. Would say if you so you can always use the ID to identify somebody for real. So if your DAO depends on the actual physical, I don't know, the real identification in the world about of a person to just hold somebody accountable, then that could be interesting. Otherwise, I don't see that it would change much for this permissioned DAO application, where you have a fixed set of members. If they have a Neo ID or not, then that doesn't really matter. I would say. I'm not so well versed in Neo ID. Of course, if you have attributes or whatever, like properties attributed to a Neo ID, maybe based on those you can give voting power, things like that. So yeah, maybe there could be interesting use cases where you could use properties from the Neo ID system in a permission DAO.
Okay, just a quick note. Sam is wondering if you could put a link to the repo for this demonstration code into the Discord.
Yeah, sure. I will do that. I don't have it up yet. I will publish it and then I'll post the link here in the devlog. And also, you'll have access soon to the grant shares contracts, which are more comprehensive, of course. But yeah, this is a nice starting example. I hope that people will be able, like other projects who want to implement a DAO, even with little functionality. I hope they can use this code as an intro, and then maybe the grant shares code for further investigations.
Okay, Redcam has an interesting question. I think he's getting deep into the details. Redcam, I'm going to try to interpret your question. If I make a mistake, please type quickly and correct me. But he appears to be asking if there's a way for people to vote perhaps on specific attributes or segments of a particular proposal, because he says, what if a group of DAO or token holders not only want to decide to either to do or not to do, or to go or no go, but what if they want to vote for a particular result, like some different set of options, and they want to vote to pick one? He's saying it's not hard to implement, but it's not easy to do perfectly. And he's also worried about storing large amount of strings that might be necessary to facilitate this and leading to expensive gas fees. And the net result of the question is, do you have any ideas or suggestions of how to implement this kind of an architecture?
Yeah, so this depends on how complex you want to have your smart contract, right? And at the moment, we're heading into a more simplistic approach to the contract itself. So the proposal is not multifaceted in this way, where you can vote on different parts of the proposal. So the proposal really just consists of these intents, and you will not vote on different parts of those intents. And we plan to just have like this discussion URL that I have here. This could be a link to a discussion somewhere online. This could be a link to a document on UFS, for example, or it could just also be the whole description itself of the project. And I think it's easier to just keep the contract simple and then do the rest in a discussion somewhere. So if you wanna if you want to vote on parts of a proposal, then just separate the proposal into multiple proposals and create them separately on the governance contract, instead of creating a more complicated proposal type and then have people vote on different parts of that proposal.
Right. And
I hope that makes sense.
And Gil's making the point that it's really is go or no go, and another alternative path is through evolution by proposal resubmission. So if the voters don't like the proposal, they simply reject it. And like you're saying on the GitHub's discussion thread, people make the suggestions of how they would like to see it changed to be approved, and it could go through that process iteratively until approval. And if I said that incorrectly, Gil, please let me know.
Yeah, I think that's what you meant. You could also then have linked proposals. So if you create a new proposal that is somehow linked to an old one, you just allow proposers to add the old proposal hash, right? So and then you can see kind of a red line through proposals that have been rejected, but then have been adapted and proposed again.
Okay, and I just want to point out that Sam is starting an online petition for a tutorial from you in Java, and it's apparently very popular already. So if you have one, please share it. If not, he says he can't find one.
Yeah. And maybe we have to work on that. Yeah. I mean, we have the documentation. We have a boilerplate codes project set up on GitHub. You can pull that and start quickly with developing. But yeah, I think there's always room for better tutorials.
Yeah, Gil just dropped a link on the Neow3j site. I want to ask you a question. I came from the Ethereum world, and over there was a standardized set of libraries by an organization called Open Zeppelin. Like one of them was a contract or library you could inherit, which helped you do safe arithmetic and avoid some of the hacks that led to the Maker DAO hack and things like that. Do you see the DAO governance system, and maybe perhaps your company could provide, where, for example, like maybe a roles library where people could be given certain roles and the library would help implement the permissions and perhaps take advantage of N3's custom groups or other permission features to make it much easier for the developer and obviously less error prone? Do you see something like that happening?
Well, Neo Foundation even gives out grants for this kind of work, right? They would support people who implement libraries with funding, and I think that's really important that we get to that point somewhere. For Neow3j, or I mean for a contract in Java, we're also planning to come up with a better system for libraries, and where you can actually just, as with normal Java application, where you can just add your library here and then use it in your contract. And I think without that, we will be lost, or we'll lose the battle with Ethereum if we don't have libraries. If you have to implement everything new again, or just copy it in. I also don't like that so much, where you just copy in a library, which then is not really, a library to me if you have to copy in the code. So yeah, and then we hope, like talking about libraries, which is something that many people will use, it's also about standardizing the governance model somehow, so that then front-end applications or back-end applications can kind of pull together many DAOs, and they know they will all have the same API. Of course, different implementations, but as similar as to the other NEPs that we have already. Something like that should be available for governance and DAOs.
All right, Redcam has followed up with another quick question. He says, will there be a general governance contract that serves like public infrastructure, or do people need to deploy their own contract based on their needs?
General governance contract. I think Moloch DAO is doing something like that, where you have a governor alpha. I don't know. I don't remember the actual code, but you can kind of fork out your own DAO from a main contract, and then your DAO will be connected to that main contract that kind of has connections to all DAOs that have been forked from there. And I don't know if you mean something like that. I'm not particularly fond of that. I think, mostly you will have some small details that you need to change for your own DAO. Or at least I would do it like that. I mean, I would not just base myself on an already existing general governance contract. It would be nice if that works, but I don't really think. I mean, definitely not there yet at the moment. So yeah.
Gil, who you may know, has another question for you. Do you think we could publish a generic DAO smart contract in Java as a Gradle Maven dependency?
Yeah, so that would be, of course, nice. If we, in this way, so if it's not a deployed thing that is general for everybody, but if you just have an implementation of a DAO, like an implementation, basic implementation of an App17 contract, and then you can just import that into your Java project and extend it and change whatever you want. So this is basic inheritance where, yeah, you get an already a ready class, and then you extend it and override the methods that you want different, and then you have your DAO much faster. That's definitely a goal, yeah.
Just a side question. I believe, what is it, RedSec or Red for Sec has been doing the contract auditing for the Neo N3 group?
Yep.
Do they do it just for Java contracts or any language?
No, for any language. I mean, they're most proficient in C# or in the .NET contracts at the moment.
Okay, good. That's good to know. All right, still waiting for any other questions to file in. Redcam is typing something right now. In the meantime, did you want to elaborate at all about your quick comment earlier about the industry moving too fast?
I don't know. I just I'm more, yeah. I'm a pretty slow guy. So yeah, just keeping up with everything in industry is quite hard to me. I try to get the right channels together now, which provide the information that I like and that I think is necessary. But all in all, I think most people would agree that you cannot keep up with everything. Yeah, thanks, Yannick. He also agrees there.
Yeah, we find it very difficult too, that to innovate has the potential to stifle you. If you put too much time on developing something innovative, somebody else may be able to develop the next step already with the pace of innovation, if you will, with people creating multiple different DAOs. It's like, well, what's the next step? What do I do next? Or how can I make my platform stand apart? So I definitely see that in a lot of the space, both in DAOs and in decentralized exchanges, and how they can, incentivize users to use their platform, right?
Mm-hmm. Mm-hmm. Yeah, I guess to me it felt for a long time. It felt like I'm running after something that we have to catch up with other chains, and I think it's just important to have a fixed vision, and then do things independently of where other people are going or other projects are going. Otherwise, yeah, you will always be running after other things, and yeah, just basic goal setting, I guess, and then getting there, and then see again what happened and where we are at.
Yeah, that's a good perspective. Thank you, Claude.
Gil has made a new comment. Yeah, he's not too fond of the public governance contract idea either. But he wants to think about it. Interesting. So it'll be interesting to see going forward how much we can standardize and provide as a base for other developers, and what just has to be done bespoke and then audited properly later. See, Gil is likes to type a lot, and he won't chime in via voice.
If you want to chat with us, brother, we're here to chat. But if you need to type it down to get it out, that's good too.
Yeah, and by the way, Redcam, I agree that, of course, if you want to avoid those 10 gas fees for deploying contracts, and it would be nice for some projects, I guess, to kind of have a public governance infrastructure they could use instead of deploying their own contract. And I guess it's not a huge step from a specific governance contract to a more general one for multiple different projects.
I think we scared Gil.
Hey guys, I'm on the go. That's why, but yeah. So yeah, great presentation, Claude. I mean, my questions here is more to brainstorm than kind of put Claude or people against a wall. But yeah, I don't believe so much on a public governance contract. I think that suggestion made by Redcam is a nice one. We're going to think about this, but the problem is that DAOs, they have like different use cases. For example, the way that members are set, the way that how would you vote, different rules on DAOs. So depending on the use case, this public governance contract can provide less flexibility, to all these use cases that are going to be built on top of it. So we were thinking about going in a different direction, saying, look, let's standardize, or let's provide a generic framework, like generic methods on smart contracts that DAOs will be able to use and deploy their contracts on that. Like, for example, create proposals, hash proposals, execute them, etc. And then like having this kind of standard will be easier to build dApps that for example, front ends that will not only target a single DAO but multiple DAOs in the ecosystem. People will be able to fork front ends to create proposals or voting or whatever, and fork and create other projects with that same standard. So I think this is one step, but I'm going to think about this public governance contract that Redcam just mentioned. Thank you.
Claude, did you want to respond to that?
No, that's just fine as you said it.
Perfect. All right, everyone. I don't see any other questions filing in, unless there's something else anybody wants to add. No, there we go. It's a thank you. We're going to close this up. I want to thank everybody for coming, and I really, really appreciate your attendance. Claude, thank you very much for a fantastic and interesting demonstration. And
thanks for having me.
Thank you, Jesse and Dolly, for helping, as your help is always appreciated. And until next time, this is Robert Oshler saying thank you and goodbye.
Goodbye, everyone.
Robert. Thank you, Claude. Thank you all.
Thank
Take
you.
care.